Alright, so our third and final video dealing with functional groups. We're going to discuss amides and amines. Alright, so again, let's do an overview like we did on the last time with the amides and amines. One thing I want you to notice is that the amide is also in the carbonyl family. The amide has a carbonyl group here, and then attached to that carbonyl there's an NH2 group. Alright, and so that differentiates amides from carboxylic acids. It also differentiates them from ketones as well as aldehydes. Alright, the amine on the other hand is a little bit different. The amine here is just a nitrogen that has alkyl groups attached to it. Alright, in this case this would be what we call a secondary amine. And again, you have to excuse my handwriting, I'm pretty new with this, but this would be called a secondary amine. Notice there's a nitrogen with two alkyl groups. So you can ask this question: what would a nitrogen with one alkyl group be considered, or a nitrogen with three alkyl groups attached to it? All right, so that's a pop quiz for you. All right, so let's look at some examples of amides and amines, and the one I want to point out is LSD. You've heard of this before. It was a drug that was really popular during the hippie movement. You know, it's a clear liquid, so they would use a medicine dropper, drop it onto a sugar cube, and the person that was taking this particular drug would put the sugar cube in their mouth and allow the sugar cube to dissolve, and the drug hits their system. And the thing about LSD is that it can really cause some long-term psychological damage. And you've heard the saying that, oh, this person is a trip or that person is a trip. Well, the whole notion of taking a quote-unquote trip comes from this era of LSD abuse in the 50s and 60s and even the early 70s. And that was even a Harvard professor, Timothy Leary, whose slogan was "tune in, turn on, and drop out." Basically, just get high until you can't get high anymore. So let's look at LSD. Here's the amide functional group. Again, it's carbonyl C double bonded to oxygen, and then connected to that is a nitrogen. Alright, so nitrogen, carbon, double bonded to oxygen is an amide. Alright, here also in LSD you'll see an amine, which is this functional group here. This is just a nitrogen bound to 1, 2, 3 carbons. I asked that question on the last slide. What type of amine is that? Is it primary, is it secondary, or is it tertiary? Right, here's also this is also another amine, and the question that comes up again: is it primary, secondary, or tertiary? I'll let you answer that in your own time. Alright, here's another example of an amine. This is methamphetamine, or meth, or the drug that's being abused, especially in lots of rural areas. And methamphetamine is this is methamphetamine here. It's derived from pseudoephedrine. That's why when you go into the store now and to buy products that contain pseudoephedrine, you actually have to show your ID, and they also keep track of how much of these products that you buy that contain pseudoephedrine. And if you're I guess suspected to be buying too much of it, then you'll probably get a visit from the cops. So methamphetamine is highly addictive. It triggers this release of norepinephrine, dopamine, and serotonin in the brain. It also stimulates this reward pathway, so that's why it's so prone to abuse. And a little did I know before preparing this lecture that Hitler actually was a meth addict. He took methamphetamine on a daily basis from 1942 until the time that he died. So let's look at the functional groups that are present. Here we have an amine. Here's nitrogen connected on one side to a carbon and on the other side to a carbon. And then in the product methamphetamine, this is pseudoephedrine, by the way. This is methamphetamine. Again, in the circle you have nitrogen connected to a carbon here and a carbon on this side, right? So this it is similar to the amine we already looked at. It's a secondary amine, right? Here's another compound that you know about. Certainly you know about it, but you probably didn't know that it was a something that we would talk about in organic. This is the structure for ecstasy. MDMA is the technical name for it. This is the name for it here. 3,4-methylene dioxy methamphetamine, right? Or MDMA for short. And little did I know before preparing this that ecstasy was used as a therapeutic marriage counseling drug, because supposedly when you take it, whatever emotion you're feeling at the time, that emotion gets heightened when you take this particular drug. And so if married couples were being counseled and they were being I guess coaxed into feeling the emotion of love, then this would heighten that emotion and supposedly bring them closer together. But eventually ecstasy started being abused in the 80s. It became a nightclub drug, and it's commonly followed by the use of it is commonly followed by severe depression. You heard about Suicide Tuesdays, where a person would take ecstasy over the weekend and by Tuesday be in such a deep depression that they want to commit suicide. Because ecstasy damages serotonin receptors in the brain. And if you look here, this is serotonin, this is MDMA, and what happens when MDMA binds to the serotonin receptors in the brain, they get damaged, and so when the serotonin tries to come back in, it cannot, because the receptor is damaged. So let's look at the functional groups. Again, you have an amine here, nitrogen, carbon on this side and carbon on this side, and then even in serotonin you have an amine shown here. Right, so let's keep going. Let's talk about some of the most important amides. Right, this is proline. Proline is an amino acid. You can see that it has an amine and a carboxylic acid functional group in the same molecule. If you look here, if we take proline and add glycine to it, we take these two amino acids and we add them together and we get a peptide. Right, this is just a very small peptide. It only has two members to it, but it is a peptide. And here, right, the connection that brings the two amino acids together here, right, that is an amide. C double bond O N, right, that's an amide. We've already talked about that. Alright, so if you take this peptide and you continue adding amino acids to it, eventually you get a protein. Right, proteins are composed of amino acids, and probably the most important protein that we know of is DNA, which is just composed of a ton of amino acids that have peptides that have amide bonds between them, and it's held together, this double helix here, held together by hydrogen bonds, which we'll talk about when we lecture on intermolecular forces. Actually cheated because I couldn't get my pen to work, but you can see that this is an amine. It has a 1, 2, 3, 4, 5, 6 carbon chain attached to it. It's also primary. This is also an amine. It has 1, 2 carbons attached to it, making this amine secondary. And then this nitrogen has 1, 2, 3 carbons attached to it, making it tertiary. Right, let's look at this side over here, where we have two amides, one where there's just an NH2 group attached to the carbonyl with a carbon chain here, and then over here this NH2 group can be substituted, so I just put a CH3 group substituent on nitrogen to show that the nitrogen of the amine can, the amide, can actually be substituted.